Good morning and thanks for tuning in to a new episode of Teaching Math 2.0. In today's episode, I will expand your knowledge on quadratic equations and the zero product property. I hope you've practiced the previous paragraphs because we're gonna need it. Welcome to paragraph 7.5. So, do you still remember how to solve x squared minus 9x is equal to 0? If you are planning to factorize the left-hand side into x minus 9 first, then you're on the right track. After we made the line x minus 9 is equal to 0, we can deduce that x must be 0 or x minus 9 must be 0. So the solutions of our equation are x is 0 or x is 9. And to solve x squared minus 8x plus 12 is equal to 0, we need to use the product sum method to find the binomial x minus 2, x minus 6. We then know that x minus 2 is equal to 0 or x minus 6 is equal to 0. So the solutions here are x is 2 or x is 6. But what about x squared plus 2x is equal to 15? If you were to start by factorizing the left-hand side to receive x plus 2 is 15, then you would have a major problem on your hand. Because now this multiplication problem states that this part times this part must be equal to 15. And there isn't just one answer here. We can have a 1 times 15, a 15 times 1, 3 times 5, 5 times 3. But there's also a minus 1 times minus 15, a minus 15 times minus 1, minus 3 and minus 5, and minus 5 and minus 3. And that's even without considering decimal numbers. So, to solve x squared plus 2x is 15, we first need to make sure that the right-hand side of the equation is set to 0. We subtract a 15 from both sides to receive x squared plus 2x minus 15 is equal to 0. And instead of looking for a common factor, we are now going to turn this trinomial into a binomial. I'm looking for two numbers that are multiplied minus 15 and added plus 2. The only combination is plus 5 and minus 3. So we can now write down the line x plus 5, x minus 3 is equal to 0. Following our usual steps, we end up with solutions x is minus 5 or x is 3. And this combination wasn't even one of the possible solutions we thought it could be. Let's now solve x squared plus 18 is minus 9x. We have to make sure that the right-hand side of the equation is set to 0. So, to counteract the minus 9x, we add 9x to both sides. As x squared and x are different terms, we cannot write this as 10x squared or something. But we write the line x squared plus 9x plus 18 is 0. If you're really stubborn, you could also write it as x squared plus 18 plus 9x is equal to 0, but only fools do that. So make sure you stick to the x squared plus something x plus a loose number form. Now that we have x squared plus 9x plus 18 is equal to 0, we can use the product sum method to factorize this and find our solutions x is minus 3 or x is minus 6. Next up, x squared minus 13x is equal to 4x. We remove the 4x by subtracting it from both sides and receive x squared minus 17x is equal to 0. As this is not a trinomial, we don't turn it into a binomial, but instead we look for a common factor, which is x. We solve x minus 17 is equal to 0 and calculate that x must be either 0 or x must be equal to 17. Pretty easy, right? Then let's continue our lesson. In paragraph 7.4, I explained how you can find the x-intercepts of a parabola if you know the formula. So, to find the coordinates of A and B, we set the formula of the parabola to 0 and solve the equation that follows. With the necessary steps, we can find the solutions x is minus 2 and x is 8. So the coordinates of A are minus 2.0 and the coordinates of B are 8.0. But what if I don't want to find the x-intercepts of a parabola, but the intersection points of a parabola and a linear function, for example, these two? In this example, the parabola follows the function y is x squared minus 6x minus 16, and the formula of the linear line is y is equal to minus 2x plus 5. To find the coordinates of C and D, I have to make an equation by setting the formulas equal to each other. So x squared minus 6x minus 16 is equal to minus 2x plus 5. We then start by making sure that the right-hand side of our quadratic equation becomes 0. We add a 2x on both sides and subtract a 5 to remove the remaining plus 5. We now have the line x squared minus 4x minus 21 is equal to 0. Then we turn this into the line x minus 7, x plus 3 is equal to 0, as the product of our numbers must be minus 21 and the sum minus 4. After the necessary steps, we receive x is 7 or x is minus 3 as our answers. But now we only have the x coordinates. To figure out the y coordinates, we do the same thing as we did in chapter 3, as we already did a similar exercise then. We just need to fill in the numbers in the formulas. Which formula you pick doesn't matter, as both should give you the same answer. So we evaluate y is x squared minus 6x minus 16 for both x is minus 3 and x is 7. And we do the same thing for y is minus 2x plus 5. For x is minus 3, both formulas give us 11. And for x is 7, we receive minus 9. That means that the coordinates of C are minus 3.11 and the coordinates of D are 7.9. Why don't you try one yourself? Let me bring out a new coordinate plane with two graphs. Your job is to find the coordinates of intersection points E and F. The parabola follows the formula y is x squared plus 3x minus 6. And the linear line is defined by the formula y is 2x plus 6. Ready, set, solve! Found the coordinates? If done correctly, you should have started with the equation x squared plus 3x minus 6 is equal to 2x plus 6. You then must have set the right-hand side to 0 to receive x squared plus x minus 12 is equal to 0. And by factorizing, you should have found the solutions x is minus 4 or x is 3. Now that you know the x coordinates, you could have easily found the y coordinates by filling in the x's in the formulas. For x is minus 4, you should receive minus 2 as your answer. And for x is 3, you should receive 12 as the y. Meaning the coordinates of E are minus 4.2 and the coordinates of F are 3.12. Next up, equations with brackets. Let me show you the equation x plus 1 x minus 4 is equal to 8. You might think, hey, this is easy, it has already been factorized. But the resulting product is 8 and not 0. So, to solve this equation, we first need to multiply out the brackets to receive x squared minus 3x minus 4 is equal to 8. We then turn the right-hand side to 0 to receive x squared minus 3x minus 12 is equal to 0. And then we factorize our resulting trinomial into x plus 2, x minus 6 is equal to 0. Following the standard steps, we end up with the solutions x is equal to minus 2 or x is equal to 6. So, if you see the equation 3x x minus 6 is equal to 9x, we first multiply out the brackets, subtract 9x to make it end with 0, factorize the left-hand side, and follow the usual steps to receive x is 0 or x is 9. And just so you don't do anything redundant, if you see the equation 3x plus 9, 2x minus 6 is equal to 0, you don't have to multiply out the brackets. The equation has already been factorized and the resulting product is equal to 0. So we can immediately continue to the line 3x plus 9 is equal to 0 or 2x minus 6 is equal to 0. Our final solutions are x is minus 3 or x is 3. Now let's do an equation that has brackets, a non-zero ending, and let's also add an extra factor to the brackets. The equation 2x minus 4 squared minus 7 is equal to minus 4x plus 15. As you might have already guessed, we first need to make sure the equation ends with 0. But the brackets are kinda in the way, so let's get rid of those first. The 2 in front of the brackets do mean that I have to double the outcome. X minus 4 squared becomes x squared minus 8x plus 16, which means that if I double that, I now have the line 2x squared minus 16x plus 32 minus 7 is equal to 4x plus 15. We can then simplify this into 2x squared minus 16x plus 25 is equal to minus 4x plus 15. By setting the right hand side equal to 0, we receive the line 2x squared minus 12x plus 10 is equal to 0. This is almost the way we want it, the only difference is the 2 in front of the x squared. To get rid of it, we have to divide every term by 2. This will cause us to have the line x squared minus 6x plus 5 is equal to 0. We can then factorize this into x minus 1, x minus 5 is equal to 0, allowing us to solve this equation with the solutions x is 1 or x is 5. How about one more? An equation that even the toughest of students struggle with. A quadratic equation that leaves the many in confusion and disbelief. How about we try to solve 3x squared minus 2x plus 8 minus 15 is equal to 2 minus x plus 3 squared. Are you ready? Then let's solve this bad boy. We see brackets, so first let's multiply these out to see what happens. Multiplying out the first brackets will give us 3x squared minus 2x minus 16 minus 15 for the left hand side. For the right hand side, we have to be careful. As there is a minus sign in front of them, that would mean that whatever we get from multiplying them out has to be multiplied with minus 1. So I will first write it down like this. Then x plus 3 will turn into x squared plus 6x plus 9. Multiplying everything with minus 1 will turn the right hand side into 2 minus x squared minus 6x minus 9. We simplify as much as possible to receive 3x squared minus 2x minus 31 is equal to minus 7 minus x squared minus 6x. The whole right hand side is messed up, but we have to set that one equal to 0 anyways. We receive 4x squared plus 4x minus 24 is equal to 0. The 4x squared is not what we want, so we divide every term by 4. We then receive x squared plus x minus 6 is equal to 0. We factorize it into x plus 3, x minus 2 is equal to 0. And using some small adjustments, we now have the solutions x is minus 3 or x is 2. And with that, we've reached the end of this paragraph. Now you know how to solve any quadratic equation the book will throw at you. In the next video, I will explain how to apply equations in situations. I highly advise you really practice the exercises from the previous paragraphs before trying to tackle paragraph 7.6. I hope to see you in the next episode. Bye bye!